Hi everyone, my name is Lydia and this is what I wish they taught me about econometrics and introduction. In this video, we're going to see our application for the IV concepts that we have seen in the previous video. So let's switch to R. We'll use the card dataset from Wooldridge. So it's data on wages and education for young men in the US. So as usual, we're going to upload the data, which is, as I said, card. We can have a look at what the main variables are in here. But we're going to use mainly wages, education. The near C4, that's the distance variable, which is going to be used later on as an instrumental variable. We've got experience, black, south, and the SMSA, which is whether you are in the metropolitan area or not. So it's a dummy variable. We can have a very quick look at the summary of these variables, and we can see from here that for wage, we've got a minimum of 4.605 and the maximum 7.78. Keep in mind, this is in logs, so don't try to give too much of an interpretation. You could have a look at wages by themselves. Then we've got education, which goes from a minimum of 1 year to a maximum of 18 years. And the near, which being a dummy variable means that it goes from a minimum of 0 to a maximum of 1. And the mean in here, the 0.68, this is basically meaning that 68% of the data points that you have in here are equal to 1, meaning near to a university. We can have a look at like what does that tell for us in terms of information, or how many observations specifically do we have near and far. So we can see that we've got 957 that are far, and 2053 that are near. So that corresponding again to that 68 and 22 ratio that we have seen before. Okay. This is again the COD 95 setting we've discussed in previous videos. We're going to first run the OLS baseline. So we've got wages on education experience. We're also using experience square. If we look at the results, we see that education is positive. Its estimation is 0.07, and we've got 3 stars here, which means this is highly statistically significant. Keep in mind, this is return to education under OLS. We suspect that it's upward biased because there is ability, which affects both education and wages. So keep that in mind, because we're going to see what happens with the IV, and we're going to make a comparison of like what was the story that OLS told us and what was the story that IV told us. So this is the first stage. Remember, in the first stage, we run a regression of the X variable, which we think it's endogenous on all of the exogenous variables plus the instrumental variable. So now we're including that distance variable, which in this case is a dummy, along with all of the previous X variables. If we look at a quick summary of the first stage in here, we see that the distance variable 0.33, and it's highly statistically significant, which means that if we're looking at the relevance condition, in this particular case, it seems to have been fulfilled. We can do, though, better than just looking at the individual test statistic. We can also check the F statistic. So in this particular case in here, what we want is from the first stage, just a summary of the F statistic, and that value is, again, 451.87. You can see that this is clearly above 10, which has been our rule of thumb, which means that our instrument is sufficiently strong. To move on to the second stage of our to SLS estimation, we have to save the fitted values, which is what we do here by first selecting the fitted values under the first stage regression, and we save them as education hat, because it means it's whatever stays after in education, the variation in education, after you've taken away that of distance and of all of the other variables in here. But we're using the X, which is everything that is explained, okay, by all of these variables right here. Before we run like the second stage, we can look at the reduced form. So the reduced form is going to be the wage directly on the distance variable. A quick summary on that shows that distance in here is 0.044. It seems statistically significant, which we really don't stop too much on because we should have argued by that point that the second condition, if we're coming up with a good instrument, we're not going to take it face value that distance is like correlated or directly doing something to the wages. Then the Wald estimator, which at this stage we are manually verifying and constructing, is the ratio between what I find in my first stage and reduced form. So the reduced form, we're going to call it gamma, and the first stage, we're going to call it pi. So my Wald estimator will be gamma 1 divided by pi 1. And finally, the actual effect that we get is the 0.13 in here. Okay. So we did all of these manually, following the Wald estimator formula. We could run it directly as well because remember, R has its own IV package. So we can use IV-reg. Look very carefully at the syntax. So as usual, we're going to have all of the variables in here. And then we've got this vertical sign, which means now we're going to write something else. And what you write next is literally the first stage regression. So as you can see, it's all of the instrumental variables in a sense, plus your exogenous variables. So it's literally what we had right here when we ran the first stage regression. So right here. If we run this and we look at the summary of the IV, we can see that ultimately education is that 0.13 that we found out of the manual steps that we took earlier with the Wald estimator. Okay, so with the Wald estimator earlier, we found that it was 0.1323, which meant that one additional year of education increases log wages by approximately that 0.13. And that matches exactly the coefficient that we find on education through the IV reg function from the AER package that runs the 2SLS basically in one step. So obviously the software is doing all the job in the background. Here we're only shown directly the result. And again, reminder, that column in here, that's the one that is separating basically the formula into parts where we have the left, the structural equation, and the right, the instruments and exogenous controls. Okay. Now, keep in mind, you never really need to run the two stages manually in practice. Most of the times, you're always going to use the IV reg. It computes also the correct standard errors. The manual two-stage gives a right coefficient, but wrong standard errors. So you can also check that very specifically by doing all of the steps manually and seeing the difference in the standard errors. So for instance, for the actual manual one that we ran, we have to do the coefficient test in here and indicate that we want the HC1 standard errors. If you don't remember why we had to do this, make sure you check the previous video that we've done on heteroscedasticity and robust standard errors. So if we do that, then we can now see the standard errors in here and the side-by-side basically comparison with the direct IV reg is going to show us that we've got for the OLS education coefficients 0.074, while to SLS was 0.13 with a difference of 0.05. And standard error comparison, we're going to see that the OLS standard error is just 0.0035, while the IV standard errors are a lot larger. And in fact, they are 14 times larger for the same theoretical reasons that we've mentioned in the miniseries videos. So as you can see, it's very straightforward in terms of showing both the two steps manually to constructing the Wold estimator or the very straightforward IV-reg. Just understand that the syntax need to include these two regressions in here, so the structural equation and the instruments and exogenous controls. As long as you remember what each of those cases gives you and what you need to fix in the end, then you'll be able to very easily make your own discussions in the end on whether you would prefer the OLS or the IV. In this particular case, in the card data set, OLS and IV tend to give similar results, which sometimes suggests that education may not be as endogenous as feared. However, so far in this video, we have not tested that formally, but that's what we're going to do in the next video. So stay tuned, and I'll see you then.